Hello, ladies and gentlemen. Let's dive into geometry today. So, geometry, a lot of people like it, a lot of people hate it. It's important to know for the SAT. So, if you don't like it, just watch this video and I'm pretty sure you're going to be very fine. Let's start with the intro. Geometry encompasses everything related to a shape. When dealing with geometry for the SAT, there are three main types of questions: perimeter, area, or volume, circles, or triangles, with emphasis on right triangles. So on the SAT, we got the formula sheet, and the formula sheet is pretty much all geometry. So as you can see, we got a circle, rectangles, triangles, right triangles, special right triangles here. And we got some volume formulas for the right rectangular prism, the cylinder, the sphere, the right cone, and the pyramid. So if you get a geometry question on the test and it talks about volume, I advise you to just go back to the first page because you know you're going to have to use one of the formulas. If it talks about area, go to the first page. If it's a right triangle, come to the first page and see if it is a special right triangle, and so on. Also, it says here that the number of degrees of an arc in a circle is 360, and the number of radians of arc in a circle is 2 pi. So that means that 2 pi radians is the same thing as 360 degrees, and that's a very good conversion to keep in your mind, even though it's written here. Understanding what that means, it's important. So 2 pi radians equals 360 degrees. And as most of you know, I'm sure, the sum of the measures in degrees of the angles of a triangle is 180. So let's dive right into perimeter, area, and volume first. So these are all different ways of referring to a shape. This is a tip that I always like to give my students. Units will tell us how to find perimeter, area, or volume if needed. So for example, if the question mentions what's the perimeter in meters, you know it should be perimeter just by the units. So let's say we're just dealing with miles, for example. So the perimeter is going to be in miles. The area is going to be in miles squared because it's base times height, or whatever shape you're dealing with is always going to be uh, miles squared or the unit squared. And the volume is going to be miles cubed. No, it's not going to be miles all the time. It's just the example that I'm giving. So the perimeter is always plain, simple. The exponent is 1. Area is always squared and volume is always cubed. So that's a very good tip. Tip 3, like I just said, the first page will have all the formulas you need for area, volume, and important information about perimeter. And the perimeter of a circle, to be more exact, is 2 pi r, which is also called the circumference. All right, let's dive into area. Area is pretty much the space inside a shape. I always like to think of houses when I think about areas. For example, my house has 200 square feet. So just think about the units, square feet. So you know it's area that we are referring to. So let's look at some examples here from previous tests. The area enclosed by a circle. Okay, so that's a keyword, area, and that's a keyword, circle. So I know I can go to the first page and look at the area of a circle, which is pi r squared. So the area of a circle is pi r squared. And it's saying here that the area is 25 pi. So area is equal to 25 pi. That's not a 25 pi, that's a 2 pi, 25 pi. Look, square inches. So even if they didn't say if it was an area, we would know just by the units. What's the length in inches of the radius of the circle? So we want to find the radius. In every geometry question, we might have the radius and try to find the area, or have the area and try to find the radius. It's both of them is pretty easy to do. It's just setting up the equation. We know the area is pi r squared, right? So pi r squared equals 25 pi. It's very simple. So we can cancel out the pi's here because they're in the same position, both on top. in different sides of the equal sign. So we have that r squared equals 25. So r equals, taking the square root of both sides, 5. Very simple. All right, let's go to volume. Same thing for area. Understand if they're talking about volume in the question, then go to the first page, and of course, know what they're asking. Number one, a box in the shape of a right rectangular prism has a volume of 60 cubic inches. So we got a volume, which is 60 inches cubed. See, cubic inches is referring to volume. And the shape, which is also a keyword, right rectangular prism. So we know I gotta go to the first page. Let's see the volume of a right rectangular prism. And this is it. Length times width times height. Okay. So the volume, so the volume equals length times width times height. So we pretty much, if you want to think about that, we have a system of equations here, and we can just sub the v in for v here, and we should be good to calculate whatever they need. If the dimensions of the box are 3 inches by 5 inches by h inches, what's the value of h? So we know that the volume equals 3 by 5, 3 times 5 times h, which is equal to 15 h, because 3 times 5 is 15. So here we can now sub in. So we have that 60 equals 15h. Now dividing both sides by 15, we get that the height is equal to 4. And we know that 4 times 5 times 3 is going to be equal to 60 if you want to check. Okay, let's do number 2. A sphere, okay, that's a keyword, a sphere, and a right circular cylinder, okay, that's 2 keywords. Both have radius r, so they have the same radius. And for the sake of not going to the first page all the time, I know what the formula of the sphere is from the top of my head. So the volume of the sphere is, actually, we didn't even read the question. Let's read it. The height of the cylinder is 18. For what value of r will the volume, okay, now we know we gotta use volumes, even though we are in the volume section, but let's assume we're just reading the question from a random question on the test. So we gotta know it's a volume first. So it's talking about volume. For what value of r will the volume of the sphere be twice the volume of the cylinder? So how can we set up this equation? I always like to just read it aloud. The volume of the sphere has to be B is the same thing as equal twice the volume of the cylinder. So 2 times the volume of the cylinder. So that's a pretty good equation to have based on the text. So if the text is not being clear of which equation you got to use, you got to interpret the text. In interpretation, I always like to think of just reading the text and just making sense, because it's pretty straightforward. B is like equal twice the volume, 2 times the volume of the cylinder, 2 times the volume of the cylinder. So it's very like in front of you, so don't overthink it. So let's see, the volume of the sphere is, if I'm not mistaken, 4/3 pi r cubed, and the volume of the cylinder is pi r squared h. Alright, so now we can set up the comparison based on the equation, and we know we gotta find the value of r. So let's do that. So the volume of a cylinder, the volume of the sphere, which is 4/3 pi r cubed, equals 2 times the volume of the cylinder, which is pi r squared h. So we got many steps on this kind of question. First of all, we gotta know the volume of a sphere in a right circular cylinder. Then we gotta understand what they're asking, right? They're asking for the value of r, given that the volume of the sphere has to be twice the volume of the cylinder. And they're also giving us that the height of the cylinder is 18. So I gotta sub that into here. So let's do that. 4/3 pi r cubed equals 2 pi Since it's a everything's being multiplied, I don't need to worry about the about distributing. It's just going to be 2 times pi r squared times 18. Okay, so that's 4/3 pi r cubed equals 2 times 18, combining like terms, 36 pi r cubed. Again, just like in this question right here, I can cancel out the pi's. And this is not cubed, this is a square, sorry. So we can cancel all the pi's. We could cancel all the r's as well, because r cubed equals r squared times r. So that's going to cancel out the r squared here with the r squared here. And the r is going to remain. So that's going to be 4/3 r equals 36. So now we can multiply both sides by 3, divide both sides by 4. So r equals 36 times 3 divided by 4. And that's equal to 36 times 3 divided by 4. That's equal to 27. So that's the radius that's going to make the volume of the sphere be twice the volume of the cylinder, because both radius is got to be the same. All right. So let's do perimeter now. Peri means around. Therefore, perimeter is calculating the sum of all sides of the shape. Most important information to know about perimeter is in the first page of the test. A circle has 2 pi radians, which is equivalent to 360 degrees. And nowadays, the calculator is going to do this conversion for you. Rest assured. If you have classes with me, just let me know, and I'll teach you how to. An angle measure of 540 degrees was written in the radians form as x pi. What's the value of x? So first of all, I know the conversion. I know 360 degrees is equivalent to 2 pi radians. So if I divide everything by 2, it's easier for me to know that 180 degrees is equivalent to pi radians. And what I always like to do in these conversions, especially if it's a ratio, is to set up a fraction. Just like we learned in the ratio section of this intensive course. So we can do that 180 degrees, 180 degrees is equivalent to pi radians. Since it's a ratio and it's constant, so it's a linear relationship, we can understand that 540 degrees is going to equal x pi radians. We don't know how much, but we can figure out, because 180 times 3 is 540, so pi times 3 will keep the ratio constant. So we know that this is going to be equal to 3. So that will be the answer. So 180 divided by pi is equivalent to 540 divided by 3 pi. If you're still unsure of what I did, just divide 540 by 3 and you're going to get 180. So that's pretty much how it works. An angle with measure of 7/6 pi radians has a measure of d degrees, where d is between 0 and 360. What's the value of d? So we just got to turn radians into degrees. It's pretty easy because we know the conversion. We know that 180 degrees is equivalent to pi radians, right? So 7/6 pi radians is going to be equivalent to x degrees. So what do? We multiply pi by, it's right in front of us, 7/6. So we got to multiply 180 by, well, 7/6 as well, to keep the ratio constant. So 180 times 7 divided by 6 to 10. So x is 10. Pretty simple.